All right, so we're on page 21. I want to help you with problem 16 just to get our brains moving this morning. And you agree we're going to have to use the cosine function since it said the cosine is 7 pi over 12. Cool. 7 pi over 12, correct me if I'm wrong, is not on my unit circle. 7/12 of a pi.
But we have 12ths. And
But could we use 12ths on our unit circle? We wrote that this was 2/12, and this was 3/12, and this was 4/12, 6/12, 8/12. Thanks, bud. And I feel like that's about all we need. Is there any way we could use those to get 7/12? 3/12 and 4/12. What about 9/12 minus 2/12? You know what I'm saying? I don't care which one we use.
I'm feeling the 3 plus 4.
I feel like we're all feeling the 3 plus. Smaller numbers, adding, not subtracting. You down with that? So we're going to go with 3/4 pi plus 2. Well, I'm sorry, 4/12 plus. Wow, I wrote all sorts of wrong things on here, didn't I? 4/12 plus 3/12 is 7/12. We concur. I'm actually going to write pi over 3 and pi over 4, though. You Gucci with that? Pi over 3 and pi over 4. Whoop. All right, I'm going to go put those in. Right here, I'm going to say 7/12 is the same as the cosine of pi over 3 and pi over 4. Then I'm going to go take this beautiful formula down here just so that we can all see it together. Sticker, that's right. Boop. All right, y'all, I'm going to go add in that I've got an alpha plus a beta. So we went alpha plus beta, so I was on the top shelf. So I'm going to stay on the top shelf. You agree over there would be a minus?
Yeah.
All right, let's write it, y'all. Let's use this whole formula. Cosine of times the cosine of. Dowdy, I appreciate you. Plus or minus? Minus, because I had a plus to start. So I'm going to stay on the top, and I'm going to use the minus there. Then what?
You're going to get a sine pi over 3.
Yep.
And then times sine pi over 4.
You know.
And then that's all we have.
That's all we have.
Then we go with it.
Then we're going to go with this thing. Cosine of pi over 3.
Cosine of pi over 3.
Cosine of pi over 3 is the x value, which is a half. Cosine of pi over 4.
Ooh.
Dowdy's on it. Minus the sine at pi over 3. Root 3 over 2. Times the sine at pi over 4. Root 2 over 2. Great. Let's multiply straight across. 1/2 times root 2 over 2. Root 2 over 4. Minus root 6 over 4. Final answer.
Root 2 minus root 6.
Is that what I wrote was my answer for number 16? Oh! I changed my mind. We're not going to do 27. We're going to do the one above it. Oh, geez. I'm just, okay. We're going to do 8. We down with that, Brady? Okay. Here we go. You guys do agree we have an alpha minus a beta. Alpha minus a beta. Alpha minus a beta. Stay on the bottom. In this case, it stays the same. On the bottom. Let's go expand this. Alpha minus a beta. Alpha minus a beta. Here we go. Sine of, in this case, x. I'm just going to go ahead and keep, yeah. I know you don't like to show your steps. I'm a step shower, Philip.
Cosine beta.
Agreed. Times the cosine. Instead of beta, what am I going to write this time, buddy? Why? It's 8. Plus or minus?
It's going to be a whopping minus.
Mm-hmm. Cosine of?
Alpha or x.
Uh-huh.
And sine of y.
Sine of y. Philip says, I'm not wasting my time. He said, I'm not wasting my time because I know the sine of x is 4/9. Can I write 4/9 in instead of the sine of x there?
Yes.
Yeah. Do I know what the cosine of y is? Not yet, so I'm going to leave a blank. Do I know what the cosine of x is? Nope, but do I know what the sine of y is? The sine of y is a fourth. Okay, so what we're going to do now is we got to go find, right here, we need the cosine of y. All I know about y is this info right here. The sine of y is a fourth. So you guys, I want you to draw yourselves a cute little triangle with an angle of y. Yep, that's why I wanted to do it with you, Beck. You're going to be fine with it. If the sine of this angle y is 1/4, so katoa, sine is always over, perfect. Opposite over hypotenuse. Opposite hypotenuse. You guys, we're going to need the cosine of this angle. So cosine is adjacent over hypotenuse. So we got, we're looking for the cosine of y, which I will need the adjacent over hypotenuse. So he's like, let's go name this. I like that, naming it b instead. I agree. So you guys, we could do Pythagorean theorem. My man Philip is just jumping. But we'd have b squared and 1 squared is 4 squared. Do you agree with that? So b squared is 16 minus 1? 15. What's b? Root 15, right? Who cares? We'll leave it as root 15 because it'd be 3 times 5 and it won't simplify. Okay. Cosine y, adjacent over hypotenuse.
Root 15 over 4.
You guys down with that? Cosine of y would be adjacent over hypotenuse, root 15 over 4. Okay, I got to go find the cosine of x. Go do that same thing. We're going to make another triangle. I've got to do another triangle because it's different angles. X and y gives me 2 different info. So I'm going to go make another triangle with an angle x since they gave me this info here. The sine of x is 4/9. So katoa, the opposite over hypotenuse of x. Yeah, opposite and hypotenuse. I'm a step shower. Bless you. 16, 81 minus 16. You can do this.
65 in my brain.
That's not a perfect square.
Is not. And that's okay. It would just be what times what? 5 times
I'm gonna say 13.
13. Agreed. Neither of them are perfect squares, so we just have the root 65, and that's
I
okay.
guess that I'm really proud of myself.
I am too.
Root 65 over 9.
Yeah, so then the cosine of x is the adjacent over hypotenuse, root 65 times 9. Over 9, my bad. You guys, we just multiply straight across. Multiply straight across.
4 squared 15.
4 root 15 over
36.
minus
Just square root 65.
over
36.
36. Oh my gosh. Can we combine the tops?
Yeah. Yeah.
4 root 15 minus root 65? All over 36? Can I say 4/36 is 1/9?
Yeah.
No.
Because it's being
Added or subtracted. And do I have anything over here that could simplify with that? I don't. But if this was like 4 over here, then I could. You know what I'm saying? Is this the answer that I gave us? Answer for number 8?